What's up, guys? I kind of have a bone to pick, and the decision I've made is that I'm going to sort of pick it by making some videos that address it. And particularly, this has to do with AI agents. So, as you can see on my screen here, you kind of have to have been living under a rock a little bit to not be aware that the current trend or the current hot thing in the AI world is agents. Everyone's talking about them, everyone has them, everybody has some sort of agentic platform that they're marketing now. Salesforce is out there referring to their agents that are doing all sorts of things. And the problem I have with it is when you hear people talk about it, a lot of times you hear marketers, salespeople, business people, they talk about these agents in such a way that it starts, in my opinion, to lead people astray what these agents really are. In my opinion, it imbues them with more intelligence and more capabilities than really exist there. That it disregards the level of engineering and developer influence that went into actually making an AI agent or an agentic system actually appear to be useful, human like, powerful. And so, what I want to do, or I guess my offering to this conversation, is I just want to make some videos that talk about what exactly an AI agent is, and then walk through actually implementing a very primitive AI agent, not using any sort of frameworks, just using the most primitive approach we can take so that we can just hone in on this is exactly what an agent is. This is how an agent comes to be. Now, the complexity of these agents, the complexities of these agent systems can become arbitrarily complex, right? Increasingly complex. But I think it helps to start with a very simple mental model so that whenever somebody's talking about these things, you can rationalize them and make sense about it without being misled, so to speak. So the first question I think everyone has when it comes to AI agents is what the what the hell are they? What the fuck is an AI agent, right? Um, because 18 months ago, 12 months ago, we were really just talking about LLMs. Generative AI was all about large language models. Now, all of a sudden, there's these agents on the scene. So, what are these agents? Is this a new type of model? Is this a new type of machine learning model? Is this different than an LLM? What exactly is this, right? And so, I think it helps to start by just talking about an agent in terms of its anatomy. And then I think that will really help drive the conversation when we start looking at implementation. So, the goal of this first video, and there's going to be probably more than one video about this, but the goal of this first video is really to talk about the anatomy of an agent, and then we'll kind of set up our project. We'll talk about the tech stack we're going to use to build our agent. We'll set up that initial project, and then in the subsequent videos, we'll start to actually implement the agent and kind of connect the anatomy to actually what happens in code and how this actually gets implemented. So, the first thing you need for an agent is you need a large language model. So, if you're thinking, are agents different than large language models? Yes, but agents depend on that technology. They depend on having a large language model. So, you can almost think of LLM as the brain, right? This is your brain of the agent, so to speak, right? So, if you were going to liken it to something else in the world, this is what I would liken it to. The LLM is what allows the agent to reason and have semantic understanding of what its goal is, right? What does the user want me to accomplish? What are the instructions that I've been given, and how should I think about them, and how should I respond to them? That's basically all the same functionality and experience that you get when you're talking to OpenAI's ChatGPT or Anthropic's Claude, or you're talking to Gemini. However, you need a couple other things for an agent or for an LLM to become an agent, right? So you can kind of think of this like uh, all agents depend on LLMs, but not all LLMs are agents, right? Kind of one of those things. So the second thing you need for an agent is you need a prompt. So almost in all cases, an agent is going to be comprised of some sort of underlying large language model and then some prompt that sort of orients the agent, gives the agent an identity, so to speak, tells the agent about the world it's operating in, the constraints that you want to place on it, and its role in that world. What are the things it's designed to accomplish or do? What's its main goal? What are its limitations? These sorts of prompts can be very simple. They can be, hey, you're a helpful assistant, or they can be uber specific and uber complex, right? Like, you're a researcher, your job is to research this particular piece of information, only use these sources, cite your research in this specific way, summarize it in this sort of structure, so on and so forth. A lot of the things you see people doing with like ChatGPT or Anthropic wrappers, where they're applying a whole bunch of context engineering and a whole bunch of prompt engineering to get a very particular response out of the LLM. Same idea here with this prompt, only now what we're doing is we're trying to kind of almost give the agent an identity, for lack of a better word. Now, the last thing is, and the final thing is really, I think, what turns an agent into an agent. Without this, I'm not completely convinced you actually have an agent. So the last thing you have is you have tools and functions. Now, I use tools and functions here because this is what most of the LLM providers out there refer to this functionality as. So if you're working with, OpenAI, you're working with Gemini, you're working with Anthropic. I even think some of the open source models that you can use with the Ollama now support this. Basically, you have the ability to do something like function calling or tool calling. What this basically means is when you send your prompt to the LLM, right? So you've got your prompt that defines this agent's identity, gives it a directive, gives it an objective. You can also define, these are the things that you can do in the world. Here's the information you need to provide in order to do that thing. And now the agent can also factor that into its reasoning about how it's going to accomplish whatever its prime directive is, or whatever the user query is. So you can kind of think of this like, for example, you could give your agent the ability to search the web or to run code. And based on the user's query, the agent could reason about, oh, I need to run some code, or, oh, I need to search the web. Now, the important thing to remember is these tools and functions aren't actually called by the agent. They are actually, maybe a better way to say it, they're not actually run by the agent, right? Tools and functions are code that I write, or you write, or an engineer or developer somewhere writes. And all the agent is doing is supplying parameters. This will make a lot more sense once we actually implement it ourselves. But all the agent is doing is saying, hey, I see I can look up what the weather is for today. I just need to provide location. And the LLM can give me a location. And then I use that location in the code I wrote to actually go and get the weather for that particular location. So this is the marriage of the probabilistic world of an LLM and the deterministic world of traditional programming, traditional engineering. And we're kind of marrying the two to try to get the best of both worlds, where we can get the semantic reasoning and understanding that LLMs provide, which is wonderful, this sort of very powerful human-like orchestration ability, with the ability for it to actually do things in a reliable way, because we've constrained it and we've made it call some piece of code that, given a particular input, always gives a particular output. And this is really what sets the agentic AI that's currently popular everywhere apart from the generative AI that we were all talking about 12, 18 months ago. So with all that being said, I think it's important now to use this as a mental model moving forward as we go forward in these videos and we start talking about implementing our own agent, to try to connect the dots. I also think having this anatomy in mind helps you simplify a lot of the talk or the conversations or the marketing or the pitching and selling that's being done out in the world. Because when someone says, I have an agent that does XYZ, or I have an agentic system that does XYZ, you can now know under the hood, oh, okay, so what they're doing is they have chosen some sort of LLM, or maybe multiple LLMs. They've given that LLM, they've spent a lot of time, hopefully, developing good prompt engineering and context engineering to help orient that agent. And then they're just providing that agent with ways to interact with other systems, or their system, or external systems, to do useful things on your behalf. Okay, that's what an agent is from my perspective. I'm sure I'm going to have people that will say, well, there's some other subtleties, but this is my mental model, and I think it's useful for me, and it's how I approach thinking about these sorts of things. Obviously, I'm open to hear your thoughts, but I think this is useful. I'm hoping all of this lands is helpful and useful. So now what I want to do is I'd like to not just talk about this in theory. I'd actually like to go through and implement this. So the first thing we're going to do is we're just going to set up our project in this video, and then in subsequent videos we'll actually get to writing some code and implementing and talking about things. So the tech stack I'm going to use actually is for my LLM, I'm going to use the Gemini API. I think the Gemini family of models are wonderful. I also think the Claude family models are fine. The ChatGPT models are fine. Feel free to sub this out if you want, but going forward in the videos, when we start to talk about how we implement this, this is the provider we're going to be using. We're going to be writing code that's somewhat specific to their API, but obviously, conceptually, you can apply a lot of these same things if you're calling the OpenAI API or you're calling Anthropic's API. I'm also going to be writing this in C# using .NET 10. So currently, as I'm recording this video, this is in October of 2025. So .NET 10 is not officially released. It won't be released until later next month, I believe, in November. However, .NET 10 provides a couple cool features that I want to use as part of this series. So in order to replicate what I'm doing, you will need to go and get the .NET SDK and install that on your machine. You should be able to just go to .net.microsoft.com and find it. I prefer to install it on my machine using Winget, but obviously you can use any of the other available options here. And I think that pretty much satisfies the requirements you need. So obviously you need access to the Gemini API. They have a pretty generous free tier, so that shouldn't be a big hurdle. And then you need to have the .NET 10 SDK installed on your machine. You need to know some C# if you want to obviously write this. Again, conceptually though, I'm hoping if you're not a .NET developer, you're not a C# developer, hopefully conceptually you can still take things away from these videos, just implement them and apply them in the language or the tech stack of your choice. So let's go ahead and get our project set up. I'm actually going to use NeoVim, or not NeoVim, I'm going to actually use VS Code for these series of videos, not because I've abandoned all hope on NeoVim, but because this new feature that I'm using in .NET 10 called single file app, or single file app support, doesn't have great support yet in NeoVim, or at least not the way my NeoVim is configured. So I'm going to use Visual Studio Code. So the first thing we're going to do to get our project set up is we really just need to make ourselves a directory. We are going to create a couple files. We're going to write a little bit of code to read our API key from configuration so that we don't put our API key in our source code. And I think that's where we'll stop today, and then we'll pick things up in another video. So let's go ahead and cd into my repository. Actually, let me make this a little bit bigger. I realize this is kind of small. Also, full disclosure, almost every video I make is like a one take thing, so bear with me. Okay, so we're gonna cd into our repository here, and then we are going, let's make something, let's call it, what do you want to call this? Agent demo. And then we are going to cd into agent demo, and we're going to make two files. Actually, let me open this up in VS Code now that I have it. We're going to make two files for ourselves, actually three files for ourselves. So we do not need Copilot at the moment. So we are going to make a file called global.json. And the reason, oops, not like that, new item, global.json. And the reason why we need the global.json is it's a .NET specific thing. If you have more than one .NET SDK listed on your machine, by default, it's always going to use the newest, right? So in this case, I have the release candidate, and I also have the .NET 9 SDK, the latest actually released version of .NET. I have my machine currently configured to always use .NET 9 by default. So if I run .NET --version, Well, let me remove that. Let me remove global.json for a second because it's airing out because it's empty, an empty file. If I run .NET -- version, you'll see it's using 9, but like I said, I want to use 10. So that's what a global JSON file is for. The global JSON file we can use to configure it to tell .NET what version of the SDK we want to use. So again, we'll go new item, global JSON. We'll open that up, and then we'll specify the SDK option. So we'll say SDK, and then we will specify the exact version that we want to use by adding a version key. And then I'm just going to list those SDK versions again so that I can copy and paste this guy. And now we should be all set. So if I run this again, you should see now it's pointing at the release candidate that I have installed for .NET 10. Now, granted, this might not be an issue for you when you watch this video because .NET 10 might be out, and that's just the latest version on your machine, and great, that's what you want to use. But if you do need to do this step, this is how you do it. All right, so we've got the global.json in there. Now we're just going to make one file. I'm going to call it, I know this is not really idiomatic for the .NET world, but I'm just going to make an index.cs file. And this file is going to serve as our one place to write all our code for this series of videos. We're just going to have our whole agent in a single file. So I'm just going to show you this working. So if I do console.writeLine and I do hello, actually let's do agent hello there. And if I go back to my terminal and I run this, I can say .NET run index.cs, and we'll see it prints agent hello there, right? I don't have a CS proj file. All of that stuff is being generated on the fly for me by .NET. I don't have to have all that set up here. This is a new feature in .NET 10. It's very cool. I'm very excited about it, and I wanted to incorporate it into these videos. So you can also, the other thing you can do is instead of saying .NET run, you can also just say .NET index.cs. So this is much more similar to like node index.js, right? Much similar experience to that, and you get hello there. So what we need to do here to get us to the end of this video is we're basically just going to set things up so that we can read our API key from configuration. So a good practice is always to read secrets from not your source code, right? So some people would argue that having these stored in the configuration file is also not a good practice. But for the purposes of these videos, I think it's plenty fine. So we're going to do appsettings.json. And then in appsettings.json, we're going to create a section for Gemini. And we're going to have one key in there for now. We're just going to say API key because that's the one secret thing that I don't really want to leak at any point while we're recording these or demoing these. And it's just good to get in the habit of always setting up projects where you're not copying and pasting secrets into your source code because it's just too easy to forget that you did that and then push something somewhere or share something with somebody and you've now leaked a secret. So it's just good to always force yourself and get in the habit of always setting up some way of accessing your secrets without putting them in your source code. It's kind of like tests. You should always get in the habit of just setting up the tests at the time you start writing or building the project. Okay, so going back to our index.cs file. So at this point now, we just need to read this from configuration. And the classic way to do this in .NET is you're going to have an I configuration. To get an I configuration, you obviously need a configuration builder. So we're going to say our API key is going to come from a new configuration builder. Now, this is a problem, obviously, because I don't have this class available to me in this single file app. But I can get it because I can install a NuGet package in my single file app just simply by referencing at the top of my file. This is, again, really similar if you're in the JavaScript or TypeScript world. This is really similar to, import such and such, right? You're going to npm install and then import such and such module. So in this case, the way we do this is we say package, right? So we say hashtag package, and then the name of the package. And so in this case, what I want is I want actually a few different packages. They're all from the Microsoft extensions namespace, and particularly the configuration extensions. Now, this isn't going to work because I haven't specified a version. So I do have to be explicit and specify a very specific version. So I'm actually going to say @ that's how I declare the version. And then I need to go get the actual version I want to use. So we'll just go back to our browser here. We'll hop over to NuGet. And we will say Microsoft.extensions.configuration. And we'll just figure out whatever the latest version of this is. If it loads. Here we go. And we'll just grab this version. We'll copy. Bring it back to VS Code. And we'll say, oh yeah, just like that. So we should find that now we can do a using statement, and we have what we need. Now, there's some other method calls or some APIs that I don't have access to because I don't have the right packages. So the other method calls I want to do is I want to set the base directory, set base path. So this is a way to tell .NET that I actually want to try to read the app settings.json file from this directory, the one I'm working in. So I want to be able to say directory.get current directory like this. However, obviously set base path is not available to me yet, so we'll clean that up with another NuGet package. And then I also want to say add JSON file, which again is another extension method that I don't currently have because I don't have packages installed. So we'll fix that in just a second. So we'll say app settings.json, which is pointing it at this guy over here. And then we'll also say optional, optional. Goodness gracious. It's not auto-completing, obviously, because I don't have those packages, so it's not aware of that method and its signature. And then we'll say build. And then once we build, now we do have an iConfiguration object, in which case now we're going to go and get that Gemini API key. So we're going to say Gemini API key, just like that. So let's clean this up finally by getting the packages we need. So the packages we need to get are under that same configuration namespace. We just need the file extensions package. And then we also need the JSON package for configuration. So let's hop over here and do JSON like that. And now, if we add some usings after it builds there, we should be able to do set base path like that and add JSON file. Very cool. And now if we run this again, let's actually print out our API key. Obviously, you don't do this in the real world. But just so that we can make sure our code is actually working, we'll say API key. And like that. And then we'll run this. So we'll say .NET index.cs. And there we go. So obviously, we'll put our real API key in there when we get to actually calling the Gemini API. But for now, this is a good starting place. So at this point, we've talked about what AI agent is, right? Kind of the anatomy of an agent. And now we kind of have a good starting point for the agent that we're going to implement. Really, the only dependency we really needed was that API key, because we obviously need an LLM that can talk back to us. But after that, all we're going to do is we're going to start to fill in what the code looks like to actually make a call to the LLM, how we define tools and functions for that LLM, how we add a prompt for the LLM so that we can create an identity for our agent and then actually give our agent some arms and legs to do things. I know this video was definitely a little longer than I planned it to be, but like I said, these are one-shot takes, so this is what it is. I don't know how many videos this series is going to end up being. I'm thinking probably 4 or 5, depending on how the recordings go. But if you enjoyed this, please leave a comment. Let me know if you want to see more videos like this. Yeah, and I hope you found this helpful and useful. And I'll see you guys in the next one. All right, bye, y'all.